Hey guys, Professor Latimer here, the CC Mom Who Loves Science, and today we're going to be talking about hands-on science experiments for CC Cycle 2, Week 14. We have two experiments that we're going to do today. One is number 165 in your Van Cleves called Cold Foot. It's on page 92. And then we're also going to do experiment number 171, which is on page 95 of your Van Cleves, and that's called Pepper Run. And so first I'm going to talk a little bit about the cold foot experiment. And so before you get started with your class, you can go over the scientific method, because you kind of use this as you go through these experiments. So I like to use the tune, the scientific method is question, research, hypothesis, experiment, analysis, conclusion. And so we'll talk about what the scientific method is. And so for our experiment today called Cold Foot, we're going to talk about how does heat travel. And later on in our memory work, we're going to learn about how different ways that heat flows, but that won't be till week 23. But we're going to talk a little bit about it today. And what you'll need for this experiment is some aluminum foil that's at least as big as your foot. So you could have one piece of aluminum foil per student if you want, and then you'll need some kind of rug or carpet samples. If you have a lot of carpet samples, each student can have their own. So you'll want to set out the foil and the rug or carpet samples kind of ahead of time or at the very beginning of the experiment. If you have like a tile floor or concrete, or you just don't want to set it up like on a carpeted floor, because we're gonna it'll be harder for you to notice a difference in the heat transfer. So you want to set out your pieces of foil and your rug, and you can either kind of go into a little bit of explanation of this experiment, or you could go ahead and do the pepper run experiment first and then come back to the foil and the rug, because you kind of want to make sure the foil and the rug are about the same temperature before you start. So I'm going to still talk about the cold foot experiment. I love Nicole Liam's science scripts. You can find these on CC Connected, and she goes through the scientific method and just some different questions you can ask. And I love this section on the bottom, has some really good discussion points. So you can ask the students, how does heat travel? And do they know that heat travels? Have they noticed things getting warmer or colder? And why is that? And why do some things get hotter faster or colder faster? So we're going to kind of talk about that. So for this experiment, you're going to have the students take off their shoes and socks. Barefoot is probably best, but if they have thin socks, that's probably fine too. And they're going to put one foot on the aluminum foil and one foot on the rug or the carpet sample. And they're going to see if one foot is hotter and one foot is colder. You can have them give a hypothesis before they do it. So do they think their foot on the rug is going to be warmer or colder than the foot on the aluminum foil? And then you're just going to observe. They're going to observe what they feel. And so ideally they'll find that their foot that's on the aluminum foil is going to be colder than the foot that's on the rug. And so why is that? So different materials transfer heat better than others. And so transferring heat just means it moves the heat from some place hotter to someplace colder. And so on week 20, we're going to learn the second law of thermodynamics. And Nicole has it written out here at the bottom. But the second law of thermodynamics states that heat will always flow from an area of higher temperature to an area of lower temperature. So what's happening, why their foot feels colder on the aluminum foil, is that foil, which is a metal, is a really good conductor. It moves heat very easily. And so what it's doing is it's taking the heat from your foot and it's transferring it to the ground. And it's doing that very easily. So you feel your foot feels colder because the heat is actually being drawn away from your foot into the ground through the foil. And the rug is not a good conductor of heat. And so it's actually keeping the heat in your foot. It's not really allowing any heat to be moved from your foot to the ground, and so your foot will feel warmer. So conductor is a good vocab word to have them to repeat and to explain. So a conductor, conduction is another word that is just when heat is transferred through a solid. And we'll learn other terms later on in our memory work too. So convection is heat transfer through liquids. Radiation is heat transfer through a gas, like through the air. But today we're focusing on conduction. So if you heat up a pan on the stove, or if you have like a cast iron skillet and you try to touch the handle, it's really hot because it transfers heat really well. But the rug fabrics really do not. So that's why in the wintertime you wear a coat made out of thick fabric, because it kind of keeps your heat in your body. So those are some points that you could talk about for for number 165, cold foot. And then we'll move on to pepper run. And this is one of my favorite experiments from this cycle. Last time we did it. And so what you'll need is a bowl of water. And if you have the resources, if you have the space, it's really fun to give each student in your class their own bowl of water and let them try this experiment on their own. Because one thing about this experiment is once you do it, you'll have to completely rinse out your bowl to start over. You can't really reuse the water once you do the experiment. So like if they can each have their own bowl with the pepper flakes, it's really fun to see their wonder and just give them the chance to do it. But this could also be a tutor demonstration too. So you'll need a bowl of water, some black pepper flakes, you'll need a toothpick, and a little bit of dish soap. So I just have a little bit of dish soap in this container. And so you're going to start by pouring some pepper flakes onto the water, and you can ask them, what do they think is going to happen when we put the pepper on top of the water? Are the pepper flakes going to sink? Are they going to float? Are they going to all move to one side? Are they going to kind of be spread out evenly? So you can ask them kind of what they think is going to happen. So I'm going to pour some pepper flakes in my water. Okay, now I'll tilt this down. So you can see that they kind of spread out pretty evenly and they're floating. And you can talk about, okay, why? Why are the pepper flakes floating? Why are they all kind of spread out the same evenly? And so water is made up of molecules, and they're tiny, tiny structures of atoms, and they love to bond together. Water molecules especially love to bond together. Basically, they like to stick together, and that's a very strong connection that they have to each other. And they're basically kind of attracted to each other. And here's kind of an illustration. This is what a water molecule looks like. It's 2 hydrogen and 1 oxygen. And they have this bond. They want to stick together. And it kind of makes a film, a skin on the surface of the water where it meets the air. Because those water molecules are sticking together so strongly. And then on the surface of the water, there's this skin. And if you've ever seen, like been to a pond or a lake and seen bugs that can walk on the water, it looks like they're walking on the water. They're so light that they don't go down into the water. That bond of the water molecules actually supports them. And sometimes you could even try this too, maybe putting a paper clip on the surface of your water. And if you can do it just right, it'll float, because that surface tension, we call it surface tension, can't be broken. That bond is so strong that if you put something very light, it will just sit on the very top. So that's what our pepper flakes are doing. They're just sitting on the top of this surface tension. Now, we're going to take a toothpick and dip the end of it in the dish soap, the liquid dish soap. Okay. And you can ask the students, what do they think is going to happen when we put the soap into the water? Get their thoughts. I'm going to show you what's going to happen. Okay, so I'm going to do it like towards the center. Okay, if you saw that, the pepper flakes spread out to to the outside. There basically are no pepper flakes in the middle. So what happened was, soap is made out of molecules too. And one side of that soap molecule is really attracted to the water. It wants to stick to the water, but the other side does not. So it's kind of like a little magnet. And so what's happening when we introduce the soap into that surface tension, those bonds between the water, it weakens the bonds between the water molecules right around it. So that water bond in the center where we put the soap is weak. But the bond on the outside where the soap did not touch, that bond between the water molecules is really still strong. So because it's stronger on the outside, it pulls away from the center and it pulls those pepper flakes with it. So that's kind of what's happening. You still have those strong water bonds on the outside, and that pulls away from the weaker bonds. They're trying to stick together, pull together even more, and it moves the pepper flakes with it. So surface tension is a good vocab word to talk about, and that bond between molecules. So something kind of cool to think about. And that water is really unique in that way, that it has such a strong bond and makes that kind of skin and film on the surface. So, and when we introduce the soap, it weakens the bond between the water molecules, which is really helpful when you're wanting to wash dishes. And so one side sticks to the water and the other side sticks to the dirt and grease, and that's what helps get your dishes really clean and washes everything down the sink. So it's a really fun experiment to see what happens to those pepper flakes when you put the soap in there. So have fun with week 14, and I'll see you guys soon.